Okay, so this is term 2, week 7, Math CA. We have a lot of new chapters, 7 and 8, all about trigonometry. You need to know the graphs of sine, cosine, and tan. You need to know the trigonometric identities. I'll go through them all three. You need to, this is old, I'll go to this. The addition formula also. I'm gonna explain everything one by one, and then we're gonna solve questions. Okay, first is the graphs. Okay, the graphs of sine, cosine, and tangent. Okay, so I'm sure many of you are familiar with this. You guys are familiar of sine of an angle, right, in degrees. So what we're doing now in grade 11 is they want you to get used to it in radians, and you're gonna be like, what's radians? I'm sure radians, you've heard it before. We've done it in grade 10. Radians is another way of measuring angles, and you're always going to see pi. You can tell me, Walid, how's pi? Isn't pi equal to 3.14? Sure, yeah, that's correct, but we're not looking at that, okay? Think of pi as 180 degrees. Pi is equal to 180 degrees. 1 pi radian is 180 degrees. It's pronounced rad. Right. Where did this pi equals 180 come from? Just so you guys can understand. You have a circle, okay? I'm going to draw a circle for you. This is where all of trigonometry originated from, okay? Draw a circle like this, okay? The radius of it is 1, okay? This is 1. What's the circumference of this circle? To go around all of it, it's a circumference. What's that equal to? 2 pi r. And this circumference, it's a rotation of how much? 360 degrees, right? So let's say the radius is 1, right? It's 1, so you don't count it. That means 360 degrees is equal to 2 pi radians. So each pi is actually equal to 180 if you divide by 2. So that's where the pi came from. Why am I telling you this? Because you're going to need to be quick. There are some special angles that you're going to need to know, just so you don't have to calculate on your calculator what's this divided by this, what's this divided by this. Anytime you see pi, if we want that as an angle, it's just 180 degrees. So the special angles that you need to know moving forward, and these are like very important, you need to be quick with these. You don't need to know them, but to be quick, know these, okay? The first one is, I'm going to write them in degrees, and then I'm going to write them in radians, okay? So the first one is, let's say sine is here, cosine is here. Anyway, 30 degrees is pi over 6. 180 divided by 6 is 30. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. 180 is obviously pi, and 360 is 2 pi, okay? You're going to see stuff like also 3 pi over 2, like مثلا 270. You're going to use this one, 3 pi over 2. You're going to see maybe 3 pi over 4, which is actually 135 degrees. I'll put it here. Yeah, 3 pi over 4. That's here. 3 pi over 2 is 270. 2 pi is 360. You need these angles, okay? Just so you see them. You don't have to memorize these, but these are so you can get used to it. Now, I'm going to ask you to memorize a few things. It's not required for the CA, but you need to know it because sometimes you won't have your calculator. And I'm expecting them to give us a no calculator AMS, okay? So sine 30 is half. Sine 45 is root 2 over 2. Pi over 3 is root 3 over 2 for sine, okay? And then sine 90 is 0, or sine pi over 2. And sine 180 is, sine 90 is 1, not 0. Okay, sine pi is 180. Sine pi is 180 is 0. And then cosine 30 is radical 3 over 2. Cosine 45 is radical 2 over 2. Cosine 60 is 1 over 2. And then radical cosine 90 is 0, and then 180 is negative 1. I should have started at 0 actually. 0 would be 0 and 1. Okay. طيب, Walid, how can I memorize? If you want to memorize this, memorize like this: 30, 45, 60, 90, 180, right? You always start at 1. It's always over 2, by the way, if you realized. Okay? It's always going to be over 2. So the way we start it is at 0 and at 1. And you start over 2, over 2, over 2. And you start radical 1, radical 2, radical 3. That's how it works. And radical 1 is just 1, so we just keep it as 1 over 2. And then for cosine, it's the same thing, but just flipped. Instead of starting at 0 and then 1, we start 1, then 0, and then we start at 3, then go down to 1. Okay, you can do that whatever you want. Anyways, so the graphs of sine, cosine, and tan. Okay, I'm gonna first start with sine x. You needed to know how radians work, just so we can be familiar. I'm sure you know that the graph of sine x looks a bit like this. Let me just draw the y-axis and x-axis. Okay, over here. Type the graph of sine x. What are our key points? You need to know that sine x, there's 3 things, okay? Whoa, pen. Sine x, okay? We were familiar with the term a sine bx, okay? What's a sine bx plus c? Let's say a sine bx plus c. A is obviously the amplitude, the maximum height. No, let's keep it in terms of a sine bx. Remove the plus c, okay? You guys know a is the maximum value or the max height or whatever. And b, it's equal to 360 over period. Right? Type. Let's take a look. Sine x, I'm going to graph the normal sine x graph, okay? We know that sine x has a maximum value of 1. Okay, let's take 1 to be over here, okay? When does it reach this 1? It reaches it at pi over 2, right? Remember, sine 90 is 1, okay? But I'm not going to use degrees anymore. I'm going to use radians. It goes down 4 squares, so 2, 4. It goes down to 0 at 180, right? And what's 180? It's pi. It goes down to 0. And then it goes down to -1 at 270, which is 3 pi over 2. Okay, so let me actually write these points. So over here, and over here, we go to 4 squares, 2, 3, 4, -1. So it's going to be over here. It goes down to -1. And then it goes back up to 0 at this 2 squares, 4 squares. It goes up to 0 back at 2 pi. Why am I saying this instead of it? Because this is how we're going to work in grade 11. Okay, no more degrees. So let's go up, down, back here. And this is the graph of sine x. What do we know? There are some certain transformations. I'm going to go through them one by one. The first one is, there's one thing. There are 2 things you should always take a look at. It's the maximum value, which is in this case 1, max value. And then there's the period, which in this case is 2 pi. Okay, or if you want, 360 degrees. Okay, this is the period. طيب, let's see. What is the first transformation I'm going to do for you, okay? You know what, actually, I'm going to do cosine and tan before going over the transformations, okay? Then I have cosine x, right? Draw the axis. You need to know over here. Okay. What are our special values of cosine? At 0, it's 1. So at 0 over here, we're going to start over here at 1. So let's label this point as 1 and go down 4 squares, again, -1. Okay, so we're going to start at 1. Type. The second special value, we always go 2 pi over 2, right? 90. So 4 squares, we start at pi over 2. How much is cosine at pi over 2? Cosine 90. If you guys want to understand, by the way, where we got the values of the cosine and sine, draw a unit circle, okay? This is a circle. If you go up 0 degrees, 0 degrees is over here. This angle is 0 degrees, right? Okay. So this point on the circle is 0 degrees. The x value corresponds to the cosine and the y corresponds to the sine. What's the x value? It's a unit circle, huh? So the radius is 1. Okay, so up here is 1. Here's -1. Here's -1. Obviously here, this point is going to be 1, 0, right? So cosine 0 is 1. Cosine, then sine 0 is 0. This is just how we got them. And then for 90, take a look at 90. This angle is 90 degrees, right? This is 0, 1. So cosine 90 is 0. And sine 90 is 1. And how about 180? These I'm just showing you. 180 is -1, 0. So cosine 180 is -1. Sine of 180 is 0. And obviously you can convert these values to radians. It doesn't matter. And how about 270? Right? This is 180, 270. You're going to get the point 0 minus 1. So cosine 270 is 0. Sine 270 is -1. That's how they got these values, actually. And 360 is the same as 0. Huh? That's how they got the values of the sine, cosine. And what's in between them? They used triangles. Anyways, So cosine of 90, how I remember it is 90 degrees. You're going to be over here. It's like how I memorize it. Cosine 90, I'm going to be at 0. When I'm up here, I'm at 0. So that's actually a way to remember it. But you're going to have your calculator at anyways. But you need to know these if you really like, you want to understand. Start getting used to the values of these angles because you're going to need them. I'm pretty sure we're going to get some sort of non-calculator exam. Anyway, cosine pi, cosine 180 is negative 1, right? So we're going to go here, negative 1. Then after that, we have 270 to 4, which is 3 pi over 2. And we know that it comes back up to 0 at 270, right? 270 cosine is 0. Okay? Then we go up to 2 pi. So 4 squares to 4. Over here at 2 pi. And the value of cosine here is 1. Okay? Let's connect the dots. You're going to get a graph that looks like this. Type. What are the characteristics? The max value is equal to 1. The period is 360 degrees or 2 pi radians. Okay, we're done now from cosine. Let's go to tan x. Okay, this is just something you need to know. Tan x. I'm going to come back to sine and cosine and apply transformations, and you're going to see tan x. Tan x looks like this. Okay, you need to remember tan is equal to sine over cosine. For that reason, okay, you guys know tan x is equal to sine x over cosine x, right? So I'm not gonna make you memorize points for tan x, other than you need to know that every odd multiple of tan x, there's an asymptote. You're gonna tell me, "Shu asymptote, what's this? Why are we having asymptotes in a trigonometric graph?" At the end of the day, this is math, right? And you have a denominator, and you know that the denominator cannot equal 0. When does cosine x equal 0? It equals 0 at two things, at pi over 2 and 3 pi over 2. So 90 degrees and 180 and 270 degrees. So for that reason, you're going to have an asymptote at these values. Okay, and if you realize the coefficient of pi in all these cases is odd. So for that reason, every odd multiple of pi over 2 will have an asymptote. Okay? And I'm going to show you how this graph looks in a second. Okay? So we're going to start numbering our graph. We have pi over 2 over here. We have the pi over here, 3 pi over 2, and then 360, which is 2 pi. Since we, by the way, plus minus, huh? Plus minus. Okay? So if you go back to the negative sense, also at negative pi over 2 and negative 3 pi over 2, you're going to have this. So let's see here. That means here at pi over 2, I'm going to have an asymptote. So my graph is not allowed to cross. And over here at 3 pi over 2, I'm also going to have an asymptote. I want to move this all to the left, to the right a bit, because I want to draw the negative sense as well. Over here, like this. Wait. Okay, I'll move it down here. Okay, let me continue the line over here and go, because I want to go to the negatives as well. Type. I'm gonna put over here 1, 2, 3, 4. Over here is negative pi over 2. So we said every odd multiple of pi will have an asymptote. So for that reason, we're gonna have an asymptote over here. So you're gonna kind of see that this graph is kind of like closing off different spaces, as you can see. Okay, so for that reason, this is how your graph is gonna look. I'm gonna show you now. What are my zeros? My zeros are when sine x is equal to 0, right? When does sine x equal 0? When is it equal 0? When x is equal to 0 or pi, right? Because sine 0 is 0 and sine pi is 0 because the y value is 0 at both these points. Okay, plus minus. Okay, so I'm gonna have a 0 value for tan over here and over here. How does it look? Do you think it's increasing or decreasing? It's gonna be increasing. How do you draw it? You start near the asymptotes, you approach infinity. You start very close to the asymptotes. As you get closer, you start to go like this, okay? And you approach the 0. As you approach the 0, you continue and just do the opposite, okay, for on the other side. That's one down. Do you continue from up here? No. Again, you continue from down. You continue, approach the 0, change direction, and just do the opposite on the other side. Okay, and your graph is just going to be repeated amounts of this. So what do we need to know about tan x? Tan x has an asymptote every odd multiple of, I wrote it here, of pi over 2. You need to know this, okay? Is there anything to do with a, b? No. Hella the transformations. For any trigonometric function, let's talk first sine and cosine. A trig b x. I'm using trig because it applies for sine and cosine. A will be the maximum value, right? And b will be 360 over period. Okay? Hella, we're gonna apply these rules and solve. Also, you can also transform the graph. You can either shift it up or down or left and right. How a trig bx plus k, the maximum value will be, now the maximum value, when you add this k, it will be your original maximum value, which is a, right? Plus your k. But now your minimum value, it won't just be negative a. No, it's negative a, but you're shifting it upwards by k, so also plus k. So that's how I got the maximum value and minimum value when you add this k. So let's say 2 sine x, the maximum is 2 and the minimum is negative 2. But let's say أنا اجيت عملت لك plus 1. The maximum now will be 2 plus 1 and the minimum will be negative 2 plus 1. Okay? That means I shifted my whole graph upwards by 1 unit. So let's say I have sine 2x. Okay? Sine 2x. It means the period, okay, b now is 2, right? And what do we know b is equal to? It's equal to 360 divided by period. So the period now, instead of being 360 degrees, because you know the period for all these graphs, for sine and cosine, is 360, 2 pi, right? It repeats itself every 2 pi, okay? It's going to be what? 360 divided by 2, which is 180 degrees. Okay, so it's going to look like this. So it's going to go like this. Let's say this is 360 degrees. It has 2 complete oscillations, or whatever you want to call it. Right. So that's the second one. So first we said a is the maximum value, and b is 360 over a period. And then we said when we add a k, the maximum value would be your original one, but just plus that k, and the minimum will also be your original negative value plus that k, right? طيب, what else? What else do we need to know? Sometimes you can see something like this. Sine x minus theta. When this theta is inside the brackets or any angle, whatever, it basically means shifted now horizontally. Okay? This is characterized by vertical shift because you're shifting up or down. When it's outside, it's a vertical shift. But when it's inside the bracket, shifted horizontally. Okay? Shifted horizontally when it's minus, shifted to the right. When it's plus, shifted horizontally, بس now to the left. هيك بنكون خلصنا الgraphs. So I'm going to solve the first 3 questions. Wow, I'm 20 minutes in just explaining. Let's go. What is the graph of y equals tan x? It cuts the y-axis at y equals 1. Does it ever cut the y-axis? It cuts the y-axis, but does it cut it at a specific moment? No. We know it passes through the origin, right? 0, 0. So it doesn't cut, no, y doesn't go through y equals 1, doesn't cut the y-axis, right? It passes through the origin, obviously, we said it goes through 0, 0. It has the y-axis a vertical asymptote? No. It repeats every pi radians. Yes. So the period of tan x, I forgot to mention this, we said cosine and sine is 2 pi radians. But tan, as you can see, it repeats itself every pi. Okay, every pi radians. The asymptotes repeat themselves every odd multiple of pi over 2. In between them, how much do you have? What's 3 pi over 2 minus pi over 2? 3 pi over 2, like just to show you, minus pi over 2. How much space do you have between them? It's going to be 2 pi over 2, right? And when you cancel the 2's, you're just going to get pi. So that actually proves to you that the period of it repeats itself every pi radians, or every 180 degrees. It only repeats every 2 pi radians? No. Even though it's correct to say it repeats every 2 pi radians, but if you say only, that's absolutely wrong. Okay? Which of the following is true about sine x? Sine x, we know it passes through the origin, starts at 0, 0, and then goes up and then goes down, right? It cuts the y-axis at y equals 1. No, it doesn't cut the y-axis. Sine, cosine, and tan, they don't cut the y-axis at y equals 1. They all cut it at 0, 0. Okay, except cosine, because cosine starts at y equals 1, you see? But sine and tan, they don't. They all have 0, 0. Except cosine, you see how it is. It starts at 1 and then goes down. Okay? It only repeats every 2 pi radians, yes. Why? Because we're talking about sine and cosine. Sine and cosine, we told you the period is 2 pi radians. Not pi, it doesn't repeat itself every pi radians. No, that's actually only half an oscillation. It has the y-axis as a vertical asymptote. No, we don't have any asymptote for sine. Okay, we're gonna come back to this. I want to continue to the graphs, okay? Over here. Here we have the graphs of y equals sine 2 theta and y equals sine theta minus 90 in a certain interval, okay? What is k? Okay, so over here we have sine 2 theta and sine theta minus 90. So I think you can guess which one is which. Obviously, our normal graph of any sine, without being the one, which one's being shifted horizontal, which one's being transformed horizontally? Which one? This one or this one? Obviously this one. What does this 2 theta do? It just makes the graph smaller. Like this is sine theta, but sine 2 theta looks like this. You see how it looks smaller? Yeah, that's sine 2 theta, the new one I just drew. Okay? Because the period is smaller. I explained why the period is smaller. I gave you the rule over here. Okay? So since the period is smaller, that's why that graph looks smaller. So anyway, that means the point on sine 2 theta, it should still have 0, 0. Okay? So that means this black graph is going to be sine 2 theta. Why? Because it's the only graph that passes through 0, 0. You can do that. Then you have sine theta minus 90. What does sine theta minus 90 means? It basically means move it to the right by 90 degrees, right? So I mean, they're asking for this k, and this k is over here. It's over here. It's, what do we know about this k? It actually is, we can see that this k is when sine theta minus 90 is equal to 1, or not 1, not necessarily, but it's the maximum value, or let's just say max. Let's say you don't know how much it's equal to, but it should be 1, right? Because there's no a. If there's no a, that means the max value, which is, let's just say 1. And at this point here, sine 2 theta is equal to 0, right? طيب, when is sine 2 theta equal to 0? It's going to be 180. You're going to tell me, why is it 180? That's a very good point. Let's take a look at the sine 2 theta graph. You can, this question has many ways you can solve it, okay? I'm going to use it this way. This is the first way I saw. The sine 2 theta has a complete rotation and ends at k. So its period is k degrees. So the period is equal to k degrees. And what's period equal to? 360 over b, which is 360 over 2, which in this case is 180. You can do that. What else can you do? You can use the first one, that sine theta minus 90 has its maximum point here. We know sine theta minus 90, it's shifted to the right by 90 degrees. You can then use, instead of shifting to the right, you take this graph and shift it to the left of it. You can see that you have 0 at that point. And you can see, okay, when does sine equal 0? At 180. You can use that, but I feel like that's a bit harder. So instead, let's use the fact that at this point over here, sine 2 theta is equal to 0. How do we know this is sine 2 theta? Because, like I told you, which one passes through the origin? Only one of them. And obviously, which one of them would pass through the origin? Obviously, sine 2 theta. The only time sine won't pass through the origin, when you transform it horizontally, okay, or vertically, okay, yeah. When you transform it vertically and horizontally, that's when it won't pass through the origin, okay. So this one doesn't have any transformation, but actually this is going to be the one that passes through the origin. So sine 2 theta, and sine 2 theta at this point equals 0. When does it equal 0? You can either say at 180, or you can just say, oh, one complete rotation, okay. Type. Now we're going to do the trig identities. It's very easy, you just need to bear with me. The first trigonometric identity is cosine squared plus sine squared is equal to 1. Let's say x sine squared x cosine squared x equals 1. How do you get this? You have the unit circle, right? We're gonna label any point over here, call it, I don't know, A. Okay, this point makes actually a right triangle, right? Right? What do we know about this right triangle? If you use Pythagoras theorem, just call this side x and call this side y. Okay, this is the height, right? That's the y value, and this side over here, x. How far horizontally? You guys know that. Let's call this hypotenuse. Let's call it the radius of the circle, right? We know that in a unit circle, right, the radius is equal to 1. So we figured out that if you use Pythagoras theorem, x squared plus y squared is equal to 1. And don't we know that when you have a unit circle, the x coordinate represents cosine and the y coordinate represents sine? Yeah, right? So that means cosine squared x plus sine squared is equal to 1. That's from where they got the rule. Type. So this is your first rule. So this is the first rule. Okay, the second rule is 1 plus tan squared x is equal to secant squared x. You can tell me, Walid, what's secant squared? And I'm going to use now another two ones that you may not know. You need to know these rules. Tan is obviously sine over cosine, okay? Secant is 1 over cosine, and cosecant is 1 over sine. You're also going to see cotangent, which is 1 over tangent. Okay, how do you get these? And an easy way for me to memorize, cosecant has s in the middle, so I represent it by sine. Obviously, cotangent is 1 over tangent, and then since there's only one left, secant, I just do 1 over cosine. This is an easy way to memorize. You can tell me, where do you get this? Using this first identity we have, cosine squared x plus sine squared x is equal to 1. If you divide by cosine squared, okay, over cosine squared. You can do it on the left, do it on the right. That's how math works. This cancels, gets you 1. Sine squared over cosine squared is actually what? What's sine over cosine? Tan. But since you have square squared, that means it's tan squared x. 1 over cosine squared, what's that? It's just secant. And since it's squared, you put squared. 1 over cosine is secant, but since it's squared, you make it squared. Is that hard? No. So actually, using the first rule, you can find this rule. And then let's see the third rule. The third rule is 1 plus cotangent squared is equal to cosecant squared. And as you guessed it, if you want to find this rule, you just divide by sine squared over here. You're going to see, let's see, how do you do it? Let's see, cosine squared x, our original rule. This is the main one. Cosine squared plus sine squared x is equal to 1. Now instead of dividing by cosine squared, let's try dividing by sine squared. Let me show you what happens. Cosine squared over sine squared. We know sine over cosine is tan, but cosine over sine is cotangent. Why? Because cotangent is just 1 over tan, so it's just the opposite of what tan is. So instead of sine over cosine, that's cosine over sine. So this cosine squared over sine squared becomes what? It has to have x, but I'm not writing it for practical reasons. Cosine squared over sine squared will be cosine over sine, we know it's cotan. But since it's squared, we make it squared. Plus sine over sine, 1. Right? They cancel. 1 over sine squared, 1 over sine we know is cosecant. But since it's squared, we make it squared x. Is that hard? No. So actually, using the first one, you can find the second one and third one. So basically, all you need to memorize is the first one. Do you need to memorize the second and third? Obviously, yes, because I'm not expecting you to derive formulas in your exam. But if you do forget, this is the main one. You need to memorize this with your heart. Okay, cosine squared plus sine squared equal 1. Memorize it. Okay. To get these, I'm just showing you. If you forget in the exam for some reason, you can divide by sine squared on both sides. You get this one. You can divide by cosine squared on both sides, and you can get this one. Type. We're done with the identities. Let's start solving, okay? And then I'll come to the addition formula. Hiking the Grand Canyon. Okay, we'll do pizza questions. The Grand Canyon is a popular hiking destination. The Bright Angel Trail is open to hikers year round, but most visitors visit from May to October, total of 184 days. During this period, 400,000 people hike the trail. On average, how many people hike the trail each day? Okay, wow. If it's 400,000 people across 184 days, I think, Yani, I'm not sure, but I think if you divide by the number of days, then you can get the average of how many people come and hike over here. So you're going to get 2,170. The round trip along the Bright Angel Trail is 21 kilometers. Hikers must complete it by sunset at 7 p.m. Alex estimates that he can hike up the trail at 2 kilometers per hour on average and descend at 3 kilometers per hour. These speeds take into account meal breaks and rest times. Using Alex's estimated speed, what is the latest time he can begin his hike so that he finishes by 7 p.m.? So here the keyword is round trip. Round trip basically means going up and going down. Okay, going up and going down is 21 kilometers. فانت this hill, you're going up and then you're going down. So let's say that distance of the hill is x. If you're going up by x and then you're going down the same x, so your total distance is 2x, and that's 21. So that means going up it's gonna be 10.5 kilometers, and going down it's gonna be 10.5 kilometers. So he's gonna go up at 2 kilometers per hour, and he's gonna go down at 3 kilometers per hour. So now we're looking for that time. Knowing our speed and the distance that we need to travel, of course you can estimate the time, right? So let's see. We know speed is equal to distance divided by time. So the speed going up, let's consider going up, right? The speed is going to be 2, the distance is 10.5, and we need to find the time. How do you find the time? It's just 10.5 divided by 2, and that's going to be 21 over 4. Okay, فعندك 21 over 4, let's say hours, right? Going up. Going down, again, speed equals distance over time. The speed is now 3. The distance is 10.5. We need to find the time. Let's do 10.5 now divided by 3 to find the time. 7 over 2. So here we have 7 over 2 hours. What's the total time? 7 over 2 plus 21 over 4. Right? So plus 21 over 4. You're going to get 35 over 4. طبعا, how are they asking? They're saying what's the latest time he can hike so that he finishes by 7 p.m. So now we have here 8.75 hours. 7 p.m. we need to subtract 8.75 hours and see what time that will be. 7 p.m. is 19 o'clock. You can do this, right? So how do you know? I know it's 19. Just add 12. So 7 plus 12 is 19. So how do I do this? 19. Do I do 19? You can do 19 minus 8.75, right? And you're gonna get 10.25. But does that mean 10:25 a.m.? Obviously not, right? It's gonna mean 10. But 1 hour is not 100 minutes. So for that reason, since 1 hour is 60 minutes, you have to 0.25 times 60. You're gonna get 15. And for those who don't know, a quarter of an hour is 15. Some people don't have to do this math. So you put 10, 15. Alex wore a pedometer for his hike up the trail. His pedometer showed that he walked 25,200 steps on the way up. Estimate Alex's average step length for the 10.5 kilometer ascent of the trail. Okay. So 10.5 kilometers, he walked 25,200 steps. We need to know how much is one step, right? So for that reason, we're gonna divide 10.5 by 25,200. We want to do it in centimeters, so you're gonna multiply 10.5 by to convert it to meters by 1,000, then to convert meters to centimeters by 100. You're gonna divide by 25,200. You're gonna get to the nearest centimeter 42. And this is very easy questions. Normally, a macaw couple lays 2 eggs each breeding season. Typically, one chick hatches successfully. For scarlet macaws, the first egg weighs approximately 85, and the second egg weighs 120. By approximately how many percent is the second egg heavier than the first egg? If you want to find how much larger something is by percentage, you subtract the second object, let's say object 2 minus object 1, and you divide it by the object 1. Okay? So, and then obviously times 100 for the percent. This is the rule to find how much larger by percent something is. So 120 minus 85. It's larger, 120 minus 85. So it's larger by 35 grams. Top 35 grams as a percentage of 85, how much is it? How do you find percentage of something? You do 35, now divided by 85, times, and now times 100. You're going to get 41%. This is, I just showed you how you use the formula, okay? Or you can just plug in the formula directly. Anna observes a colony of 8,000 macaws, 4,000 pairs at the beginning of the year. Okay, so 4,000 pairs at the beginning of the year. Each pair successfully raises 1 chick during the breeding season. Okay, so that means 4,000 pairs makes 4,000 chicks. By the end of the year, 15% of all the birds will die due to natural causes. At the end of the first year, how many macaws are there in the colony? So you have 4,000 pairs, right? That means 8,000 macaws, right? 4,000 pairs raise 4,000. So now I'm left with how many? 12,000. Why? Because this is 4,000 pairs raises 4,000 chicks, right? Then they said 15% will die. So what's 15% of 12,000? So 0.15 times 12,000. That's 1,800. So 12,000 minus 1,800, that's 10,200. Anna predicts the colony will grow as follows. At the start of each year, the colony consists of equal numbers of male and female macaws who form pairs. Each pair raises 1 chick per year. That's pretty obvious. By the end of the year, 15% of all the birds will die. 1 year old macaws also form pairs and raise chicks. Based on these assumptions, which of the following formulae describes the total number of Macaos P after 5 years? So if you're lost in the exam, you can try each formula on here and see which one works. But I asked ChatGPT because I'm kind of lost. I don't know why. But you can take this. Okay, the population growth is equal to population one, like P0. Okay, how much you have at the start times 1 minus r to the power of n. Okay, r being your percentage ratio and n being the years. Okay, so population is equal to, in this case, 8,000 times 1 minus 0.15 to the power of 5. You can tell me, why is it now 1.5? There's also something called a population growth ratio, okay? It's going to be 1.5. Why is it 1.5? Because here the ratio is 1.5. You'll see we started with 8,000 Macaos and we ended up with 12,000. What's the ratio? Okay, right, 8,000, we ended with 12,000. Okay, the growth ratio is 12,000 divided by 8,000, which is just 1.5. Okay, so that's something that we usually add in the formula, but in most cases it's not present, so that's why we leave it out. Okay, so it's 8,000 actually. So the formula is P equals P0 times the growth ratio times 1 minus R, all of that to the power of n. Okay, so it's going to be 1.5 times 1 minus 0.15 is 0.85 to the power of 5. So you can actually try this on the numbers here and see if it works, and it will be correct. Anyway, question 6. Now that we know the another pizza question. Okay, the function f is defined as the graph of f of x has x-intercept a comma 0, y-intercept 0 comma b. Okay, where a plus b is equal to 4. The function h of x equals f of x plus 1 has x-intercept c comma 0, and the function g of x equals f of x plus 3 has y-intercept 0 comma d. Find the value of c plus b. So this actually uses the transformations we need for sine and cosine. As you can see here, f of x plus 1 basically means we shifted it to the left, right? And we know f of x, the x-intercept was a. So since you're doing x plus 1, don't be fooled, it doesn't mean a plus 1, no. I told you always you do the opposite for horizontal shifts, okay? Horizontal shifts, when it's inside the brackets, you do the opposite. So since it's plus, that means you're going to the left, you subtract. So instead of the x-intercept for f of x being a, h of x, the new x-intercept now will be a minus 1, because we're adding 1, okay? So a minus 1 is equal to c. Okay, so the x-intercept of h of x is c, and we know it's equal to a minus 1. Why? Because they said f of x plus 1. So a minus 1. Then for the y-intercept, d, it's actually equal to b plus 3. Why? Because when it's outside the brackets, we say it's a vertical shift. You're now going up by 3, right? So when it's outside the brackets, add the vertical shift, you do as it is. So b plus 3. Type, they want c plus d. What's c plus d? So they want a minus 1 plus b plus 3. We know a plus b is equal to what? 4. So we're going to replace this with 4. So you're going to be left with 4 minus 1 plus 3. You can get 6. These questions are extremely easy. I don't think they need any thinking at all. Okay, let's go. Tan x is equal to 7 over 5. What is the value of k if secant squared x is k over 25? Relate tan to secant. We know 1 plus tan squared is equal to secant squared. So that means secant squared is just going to be equal to what? 1 plus tan squared. So 1 plus 7 over 5 squared. Let's do it fast. 1 plus 7 over 5 in brackets, okay? 7 over 5 squared. 74 over 25. So k is 74. Extremely easy. Question 9. Given that cotangent x is 5 over 4, what is the value of k if cosecant squared x is k over 16? How do you relate cotangent to cosecant? We know 1 plus cotangent squared x is equal to cosecant squared x. So you're going to do, what's cosecant squared x equal to? Just 1 plus cotangent squared. So 1 plus 5 over 4 squared. Right? So 1 plus 5 over 4 squared. So it's going to be 41. K is 41. Question 10. Okay, Hella, I think all of these are left are sine a plus b. Yeah. Okay, I didn't do question 3. Sine squared plus. Okay. Given that sine squared x is equal to 3 over 8, what's the value of 160 cosine squared x? First, let's find what cosine squared x before finding 160 cosine squared x, right? So we know sine squared x plus cosine squared x is equal to 1. So what's cosine squared x going to be equal to? It's just going to take sine squared there. It's going to be 1 minus sine squared x, right? So let's do 1 minus sine squared. They gave it to us. So 3 over 8. You're going to get that's cosine squared x. But times 160, it's going to become 100. Very, very easy. Hella sine a plus b difference formulas. So now we have our sum and difference formulas. Okay, very, very easy, but it comes memorizing. To explain this, I'm not going to bother. If you want to read the explanation and you're curious, please open the textbook. But sine a plus b is equal to sine a cosine b plus sine b cosine A. Sine A minus B is equal to sine A cosine B minus sine B cosine A. Cosine A plus B is equal to cosine A cosine B minus sine A sine B. Cosine A minus B is equal to cosine A cosine B plus sine A sine B. Memorize, okay? Memorize. I cannot explain it because, like, guys, I'm just gonna end up complicating you, okay? It has to do with triangles, okay? But the proof is, it's nice if you want to read it really and you have time. وانت فاضي عن جد. Read over the proof, it's very nice. But anyways, question 10. Given sine A is equal to 21 over 29, cosine A is 20 over 29, sine B is 3 over 5, and cosine B is 4 over 5. What is cosine A plus B? Cosine A plus B is cosine A, cosine B, minus, okay? Remember, for cosine, it's opposite. When you have plus, it's minus, okay? Sine A, sine B. So it's gonna be cosine A, which is cosine, let's just, they gave it to us. Cosine A is 20 over 29. Cosine B is 4 over 5. Minus sine A, which is 21 over 29. Times sine B, which is 3 over 5. So here they were nice. They're testing on the formula. This is a direct application of the formula, but there will be other questions, and I'm going to show you in a second, where they only give you sine A and they only give you cosine B, and then they tell you what's cosine A plus B. So then you would have to figure out what cosine B is, and you'd have to figure out what sine B is. And to do that, you need to use the Pythagorean identity of cosine squared minus sine squared, where we're going to come to a question like that in a second. So let me stop yapping and just put the fries in the bag and solve. You're going to get 17 over 145. So K is 17. Okay, perfect. We have 15 questions. Yes, 15 questions. Question 11. Again, here they gave you all the values. Okay, what's the value of K if cosine A minus B equals K over 65? Again, cosine A minus B now is going to be, it's the opposite for cosine. So when you have minus, it's going to be plus sine A sine B. Very easy. Okay, so cosine A will just be 12 over 13. Times cosine B, which is 4 over 5, times, plus sine A, which is 5 over 13, times sine B, which is 3 over 5. Very, very easy. 63 over 65, K is 63. Question 12. What's the, oh, في tan كمان, I forgot about tan. So for tan A plus B, it's equal to tan A plus tan B over 1 minus tan A tan B. How do you memorize this? I memorize like this. Plus, so they're always different. The one up is different to the one down. So if it's plus here, then the one up always follows it. So it's going to be plus. And since the one down is opposite, it's minus. Okay, so I memorize sum over product, sum over product, sum over product. If you want to derive this, here's what you do. Tan A plus B is the same as sine A plus B over cosine A plus B. And if you just plug in these two rules over here, you're going to get that it's actually equal to sine A cosine B plus sine B cosine A over cosine A cosine B minus sine A sine B. And then if you divide by cosine up and down, divide by cosine A cosine B up and down, okay, over here cosine A cosine B, over here also divide this one by cosine A cosine B, we're gonna get this one cancels, okay, so the denominator you can get 1. Sine A over cosine A is tan A, so these two cancel. Sine B over cosine B is gonna be tan B. Sine A over cosine A is tan A, and then cosine B over cosine B cancels. Okay, so we're done from this. Sine B over cosine A, sine B over cosine B, they cancel with each other, so you're gonna get tan B, and then cosine A over cosine cancels. Okay, so you're going to be done, and this is what you get at the end. Okay, tan A plus tan B over 1 minus tan A tan B. So if you want to derive this knowing sine and cosine, you can derive this in the example. Okay, type. And obviously for minus it's just going to be the same thing. It's going to be tan A minus tan B over 1 plus tan A tan B. Okay, if you need minus, which you probably will actually. Okay, so what's the value of k of tan A minus B? Tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. Let's take a look at what we have. We have tan A and tan B given. So 4 over 3, we're going to put a fraction. Always put a fraction first. So you're going to put another fraction, 4 over 3, minus, within the fraction, tan B, which is another fraction, 5 over 12, over 1 plus tan A tan B. So 1 plus, let's put in brackets now, 4 over 3 times 5 over 12. Close the bracket. Let's see, 33 over 56, okay, is 33. Very, very easy, very, very simple, very good, very nice. Given sine A is 29, cosine B is 4 over 5, where A and B are in the first quadrant. What is the value of k if cosine A plus B is k over 145? What is cosine A plus B? Cosine A plus B is cosine A, cosine B, minus sine A, sine B. But what are we missing? We're missing cosine A and we're missing sine B. So can we find them? People are going to say, they're going to say, I don't know. People are going to take a look at this and they're going to be like, we don't know shit, bro. What am I looking at? Okay, so here's what you're going to do. What do we know? We know sine squared plus cosine squared is equal to 1. This is completely normal if you don't watch this. Aslan, that's the reason you watch my videos, to learn. And I'm here to teach you, not to make fun of you, not to put you down, not to make you feel pressured in any way whatsoever. So I'm not here to shame you or make fun of you. I don't want to make you feel down. At the end of the day, I'm here to help. I'm here to teach you. You're here to learn from me, and I shouldn't expect you to know things. And that's completely normal with this, with the pressure of the school, with the pressure of the Sabbath system, with the stress we all have, whether it's school related, whether it's friends related, whether it's relationship related, whether it's family related. I feel you. Okay, so it's fine. Okay, never ever think I would like seriously make fun of someone if they're stupid. I'm not like this. Okay, at the end of the day, I'm here to educate you, and that's my job. Let me cut to the chase. Sine squared plus cosine squared equals 1. If you ever have one of these values, you can find the other. Okay, so let's say I have sine A and I want cosine A. We know that sine squared A plus cosine squared A is equal to 1. So if you ever want to find cosine squared, and I memorized it بسرعة خلص, I said no, let me not waste time, and instead of writing all this, cosine squared is equal to 1 minus sine squared. That's how I have it memorized. So if I found cosine squared of A, it's going to be equal to 1 minus sine squared of A. Okay, because if you just take it to the other side, so I have it memorized like this. So that means cosine A, okay, would be square root of 1 minus sine squared A. Okay, so let's do this as سريع. So it's going to be square root of 1 minus sine squared of A. So you have to square this 21 over 29. Okay, 21 over 29 squared. You're going to get 20 over 29. Okay, so cosine A is going to be 20 over 29. Okay, perfect. How about sine B? I need sine B, right? How do I find sine B? Using the same method. Sine squared would be equal to 1 minus cosine squared. Okay, so sine would just be equal to, sine of A would be equal to square root 1 minus cosine squared of A. Okay, let's do it on our calculator. Square root over 1 minus, over here you have cosine squared, in brackets, cosine here is 4 over 5. So let's square it. You're gonna get 3 over 5. So cosine, sine sine B now is equal to 3 over 5. Perfect. Can we now do this and do the formula? Yes, of course we can. So cosine A plus B will be cosine A cosine B minus sine A sine B. So cosine A cosine B. So we're going to use cosine A, which we found to be 20 over 29, times cosine B, which is given as 4 over 5, plus, because minus, because they're saying plus here, so minus sine A sine B, so 21 over 29, times sine B, which is found as 3 over 5. Let's do it on our calculator. We're gonna get 17 over 145, so k is equal to 17. Okay. Question 14. Sine A is 21 over 21, cosine B is 93 over 5. What is cosine A minus B? Okay, but here they're in the second quadrant. Okay, this is important. I didn't touch on it here because this is wrong. I should have explained it. First quadrant, sometimes they might see third quadrant. Okay, what are quadrants? Okay, some people know this, some people don't. Over here is quadrant 1, over here is quadrant 2, over here is quadrant 3, over here is quadrant 4. Okay, in quadrant 1, cosine is positive, obviously, because x is positive, and sine is negative. Over here in quadrant 2, cosine is negative, because the x values are starting to become negative, right? But sine is still positive, okay? So I put cosine negative, sine is positive. Over here in quadrant 3, they're both negative, right? Just take a look at what's negative. X and y are both negative here, right? And over here, cosine is positive, but sine is negative. Type. Why am I saying this? Because now when we got cosine always has two solutions. The rule for cosine is actually is 360 minus whatever answer you get. So you get the solution theta, okay, and 360 minus that solution. For sine, it's equal to the solution theta, and the second solution would be equal to 180 minus that solution. Okay, these are the rules, and you need to know these. In case they say, like here they said first quadrant, so I didn't have to do anything. It's positive. So first quadrant, that means the answer for cosine should get is positive. The answer for sine should also be positive. But when I got مثلا, let's say I got cosine, I think sine B to be 3 over 5. Okay, let's say they said fourth quadrant. Okay, fourth quadrant معناتها my sine should be negative. Okay, or no, that would be sine B 3 over 5. Let's say second quadrant. Okay, second quadrant. Let's say you said second. Okay, 3 over 5, that's correct because second quadrant is positive. But and I got cosine A 20 over 29. I'm trying to give an example. If they said second quadrant, you know that cosine is negative. So مثلا this cosine A 20 over 29 ما هتظبط. Okay, so what do I do for it? It should also be negative. Why am I saying this? And you're telling me, well, how do I make this negative? ما انت مش cosine wasn't cosine equals square root of 1 minus sine squared? Didn't we do this to find cosine? Yes. But you know, square root can either be positive or negative. And to choose which one is, to choose if you get a positive square root or the negative square root, which one you should choose, it depends on the quadrant. Since they said the first quadrant, that means for sine and cosine, I should have gotten the positive square root. But let's say they said is quadrant 2, then I'm not going to take the positive, I'm going to take the negative, because cosine should be negative in quadrant 2. Okay, that's just so you understand in case it comes in the exam. I think for 12 it didn't come. Here they said second quadrant. See, second quadrant and the cosine should be negative. Okay, so here now when I get cosine, remember cosine I'm just gonna do it fast. Cosine squared is equal to 1 minus sine squared. Okay, so cosine will be square root of 1 minus sine squared. So let's see, positive square root or negative square root. Since we're saying second quadrant, that means cosine is negative, sine is positive. Over here negative, positive, right? طيب, let's do square root of 1 minus sine squared. So 21 over 29 square, you're going to get 20 over 29. So cosine A is going to be 20 over 29. But are we going to take it positive or negative? You can take it negative 20 over 29. If this was a written exam, you're going to say cosine A is equal to plus minus 20 over 29. And then say positive 20 over 29 is rejected. Why is it rejected? Because you're in quadrant 2. Okay, Q2. Okay, it's written like this. So cosine must be negative. Okay, if this was written. But we're not doing that all out. Okay, so cosine is 20 over 29. So cosine is negative 20 over 29. طب how about sine B? How do we do sine B? Sine squared is equal to 1 minus cosine squared, right? So if you want sine, you just do square root of 1 minus cosine squared. So it's going to be square root of 1 minus negative 3 over 5 squared. Over here, you can get 4 over 5. So sine B is equal to 4 over 5. Now they want cosine A minus B. So what are we going to do? Cosine A, cosine B, plus sine A, sine B. Okay, on our calculator, yalla. Cosine A, cosine B, so it's going to be, where do we find cosine A? It's negative 20 over 29 times cosine B, which is negative 3 over 5. plus sine A sine B, so sine A is 21 over 29 times sine B, which is 4 over 5. You can get 144 over 145, so K is 144, okay? Question 15, okay, cosine A is 5 over 13, sine A is 12 over 13, cosine B is 3 over 5, sine B is 4 over 5. What's cosine A plus B? You have all of them, so you can just do direct multiplication. So it's going to be cosine A, cosine B, minus sine A, sine B, okay? So you can do cosine A, cosine B, so get my calculator, cosine A, cosine B, so it's going to be 5 over 13 times cosine B, which is 3 over 5, minus sine A sine B, so 12 over 13 times 4 over 5, okay? You get negative 33 over 65, so the box is negative 33. Please, 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 please remember the rules, okay? These, you must memorize all of these. Okay, let me go down. Okay, all of these, okay? You must memorize all of these, okay? You should also memorize at least cosine squared x plus sine squared equals 1, okay? Actually, you know what? Memorize all three. No, I'm not going to tell you memorize at least, because I know for a fact you guys will not be deriving in the exam. Okay, so memorize first one, second one, and third one. And memorize the graphs. They're pretty self-explanatory as long as you pay attention. Thank you so much for watching, and good luck in your exam.